Hi and welcome to the 7th video on kinematics. Today's question reads, a motorcycle police woman hidden at an intersection observes a car that ignores a stop sign, crosses the intersection and continues on at a constant speed of 72 kilometers per hour. Just as the car crosses the intersection, the policewoman starts off in pursuit, accelerating uniformly at 3 meters per square second until she catches the car. The questions that we have are, how long does it take the motorcycle to catch up with the car? The second one is, how far will the car move when this happens? Okay, let's begin by visualizing this situation. So we have a car at a stop sign. This is an intersection of two roads. We are told that the policewoman is also at the intersection, but she's hidden at the intersection. This car goes on to ignore the stop sign and travels some distance in this direction, ends up somewhere here. We don't know how much he ends up, but we are told that he moves with a constant speed of 72 kilometers per hour. That means that he's coming here with 72 kilometers per hour. Or let's convert it in advance. So 72 kilometers per hour is 20 meters per second. So he's coming from this side with 20 meters per second. And he continues with that constant speed until he reaches some distance. The policewoman, immediately we are told that just as the car crosses the intersection, the policewoman starts off in pursuit. So just when this car crosses the intersection, the policewoman also begins her pursuit. They travel some distance, the same distance, and the car is caught. So we have this distance here. Let's call it S for the displacement, because at this point gets caught. The car gets caught at this point. So our task is to find, first of all, the time it takes for the policewoman to reach this distance and the displacement at which this car will be caught. So here we have 20 meters per second. The information we have about this policewoman is that she's accelerating uniformly the whole time at 3 meters per square second until she catches the car. So for this entire period and this entire distance, she is accelerating. Okay, so let's separate these two. We have the car on the left hand side and the policewoman. We have the car and the policewoman. So because the car is moving at 20 meters per second and we are told that this is constant. Because it's constant velocity, we can get the displacement using the equation S equals Vt. On the policewoman side, we are told that she accelerates uniformly. So when there's acceleration, we have to pick one of the other kinematic equations, which is S equals V naught T plus half AT squared. This is the equation that has time and acceleration. We're also trying to get the displacement. Now let's look at this. The only piece of information we have about the car is that it travels at 20 meters per second. We don't know the displacement. We don't know the time. But on the policewoman side as well, we don't know the displacement and we don't know the time. So what we're going to do is make an equation for the car. The equation will have S, and the policewoman side will make an equation which will also have the S. Then we'll solve the two equations simultaneously because we have two unknowns which is s and t. When we have two variables, we need two equations to solve for those variables. So let's plug in velocity on the car's side. So s is equal to 20t. So we can call this equation 1. Then on this other side, we have s is equal to initial velocity. What's the initial velocity of the policewoman? We are told that she starts at rest, because the policewoman was at rest when the car was passing, but just when the car reached the intersection, she started off. That means that her initial velocity was 0 times time plus half, and we've been given her acceleration, and time squared. So this one becomes s equals 0 times time, that's 0, plus we can write this as 3 over 2 t squared. That means that this one is 3 over 2 t squared, and this is our equation 2. Now that we have these two equations, we can solve equation 1 and equation 2 simultaneously. Equation 1 is s equals 20t. So we can use substitution method here. We'll sub equation 2 into equation 1. So s is equal to 3 over 2t squared. So on the left hand side, we'll sub 3 over 2t squared is equal to 20t. Now with this, we can solve for t. So let's begin by multiplying the entire equation by 2 to get rid of this 2 in the denominator, so that this 2 and this 2 will cancel. On the left hand side, we'll have 3t squared. On the right hand side, it will be 2 times 20t, that's 40t. Now let's bring this part to the left hand side so that we have 3t squared minus 40t is equal to 0. At this point, we can factorize t. Then we'll have 3t minus 40 is equal to 0, giving us two answers. T is equal to 0, or 3t minus 40 is equal to 0. This one gives us 3t equals 40. Divide both sides by 3, leaving us with t is equal to 13.3 seconds. Now, of these two, which one is the appropriate answer? We know that some time passes. That means that this answer is incorrect. The reason we've gotten two values of t is because there was a time when both of them were at the same displacement, which was here. The displacement was 0 and the time was also 0 at this point. But the other value of t is for when the car reaches some distance. So our answer for time is t equals 13.3 seconds. So we've gotten our value of time, t equals 13.3 seconds. Now let's get the value of the displacement. From equation 1 was s equals 20t. We'll plug the value of t we've gotten into this equation. So 13.3 seconds. So that's 20 multiplied by 13.3 seconds. That gives us 266 meters. And that is our displacement, s. So s equals 266 meters. That means that at the distance 266 meters, after 13.3 seconds, the policewoman finally catches up to this car that crossed the intersection.